Oh no, the killer must have followed her on vacation. But to find them, we would have to search through 200 megabytes of emails looking for something formatted like an address. It's hopeless. But wait, after today, we know regular expressions. Now, there's a lot to the theory of regular expressions, and that is something that you can learn more about on Wikipedia if you're interested in it. Basically, regular expressions are a computational model. And they're not quite as powerful as a real full-fledged programming language, meaning a regular expression is not Turing complete, but it is very powerful as find and replace, and that's what we're going to be going over. Regular expressions can be a little bit hard because there's a lot of jargon associated with them, but they are extremely powerful. And when you know how to use them, that means that you'll find a lot of tasks that become much, much easier when you know regular expressions. For instance, going through 200 megabytes of email and finding anything that looks like an address. We'll start with the most basic uses of grep, but by the end of this series of lectures, you too will be a superhero. The example file that we'll be looking through comes from the VLC source code. So I took an old version of VLC right here. It's open source, so everything is freely available. Took out the TCP, or internet connection, software from it, and we'll be using that to search through. The most basic use of grep is just a pure, simple find. So for instance, let's say that we're programmers. We want to find the word include to see all of the libraries that TCP includes. To do that, I can say grep. Grep is the name of a utility that does find over files. Then you say what you want to look for. So in this case, we want to look for the word include. Then we specify what file or files we want to search over. So tcp.c. If you want to search over multiple files, grep lets you do that just fine. So I can say grep include, and then instead of tcp.c, I can specify vlc-1.1, and I can say, since I'm in Z shell, I can say everything that's in that folder or a subfolder of that and every file. And you'll see that there's a ton of things in there because there are a ton of things that say include. I'll stop it short here, just so that since you've already seen exactly how much grep can do. That means that if you want to search for anything across many, many files, you can do that by just grepping for it. Let's say that we want to search for hello world within tcp.c. Now, this is a slightly modified version of the file, so there might actually be hello world inside of it. Let's say grep hello world tcp.c. So it found a line that has hello world on it, but what's this up here? We didn't get an error the last time, so it doesn't really make sense that we would have it. It's saying that there's no such file or directory called world. It makes sense if we look through this that it would actually give us this error though, because I told you before what we did last time was grep for the word include in tcp.c. And I just showed you that if you grep for multiple files, then it can find it in multiple files. Thus, when I say grep hello world tcp.c, it's grepping for hello in the files world and tcp.c, and it's saying I cannot find the file world. What that means is that if you ever want to search for something that's multiple words, you have to do it with quotations. For instance, grep hello world tcp.c. And what this does is it tells the shell to interpret this as one single argument and pass it as one single argument so that grep considers it as just one thing. And you can see that works and it doesn't give us any errors. Another thing is if you're in a shell like C shell that might not deal with quotations the same way or something like that, you can always just escape the spaces. What that means is if I say grep hello \space world tcp.c, that will say that here, this backslash space does not mean a real space. What that means is a space character. So the space will not separate the arguments in the shell, it will only appear as a space to the program grep. That's a little bit sophisticated. If you don't understand that completely, that's fine. The bottom line, if you're using a shell like bash or Z shell, you can use quotes. If you are using something like C shell, then you might have to use a backslash space when you want to grep for something that includes a space. So you can see that works completely fine. But that's not what makes grep powerful. What makes grep powerful is that you can do a lot of things with wildcards. The most basic wildcard is the dot. When you have a dot, that lets you find any character. So for instance, if I grep for dot in tcp.c, then that'll match every line because the dot matches every character. Let's say that I want to see whenever in in this tcp.c file there is the word snack or smack. To do that, you can say grep s.ack tcp.c. This dot will match any character, so it'll match smack, snack, and s anything else ack. You can see there's a line that includes snack and a line that includes smack. But if you had to specify exactly what you wanted to do, then that wouldn't make your grep regular expressions very exciting. So you can also do repetition. The star character means repeat 0 or more times. What that means is that if I grep a star in tcp.c, oh, it doesn't find anything, because the star character here is being interpreted by the shell. So you can see this is Z shell that is giving an error. This isn't grep that's giving an error. If I want to change that, I would have to say grep quote a star tcp.c, or alternately backslash star, just like you could do backslash space. But wait, I said a star, and here it's giving me the line free PIFD. That doesn't have an A in it. The key thing to note is that star will match 0 or more, not 1 or more. What that means is that it's most useful when you want to surround it with something. So let's say that I want to find every line that has null on it. And one way to do that, if we didn't want to just grep for plain old null, would be to grep for n dot star space. This will match null, n, followed by any characters, followed by a space. So here we can see we mostly get null, but we also get a few other random things like connect, negotiate, and if we look a little bit up, we can also see that we get something like some pound defines. We even get this line at the top because it has the capital N from GNU, followed by a space. So a lot of times just using the dot can be a little bit crude, but at the same time, it is very powerful. But now, in order to complete the motivating example, we want to do anything that looks like an address. So let's say that anything that looks like an address has to start with a number. And actually, not just one number, but one or more numbers, because an address can have any number of numbers. Then it'll have a space separating the street number from whatever the name of the street is. We don't have information about the street name, so we just know that it'll be some character or some number of words followed by a space. And then after that, there's probably going to be a state name, so since this is a US address, so that's going to be 2 letters that are capital. And after that, there's going to be a zip code, one space after this state name, so that's going to be some sort of number that is repeated 5 times. Let's see if this works. Oh, it finds the one address in the file, which is 51 Franklin Street, 5th floor, Boston, Massachusetts, 02110. And that is grep.